Okay. So first thing we talked about in this unit. Okay, so Unit 4 exam review. First thing in this unit was climate, right? Remember, the components of climate are temperature, precipitation, light, and wind. Those are the components, the four of them, right? Then there are the factors that affect the components, right? The factors, the big ones, would be things like latitude, altitude, proximity to oceans, okay? Proximity to mountain barriers, centers of high and low pressure, ocean currents, all of that kind of stuff, okay? Those are the things that can affect your precipitation, your temperature, your light, your wind. Right? There will definitely be a written response question that will involve you having to talk about the factors that affect climate. Here's how it's going to work. I'm going to give you a map of Canada. I'm going to identify a location on that map. And I'm going to ask you to tell me what you think the climate will be like there. That is, describe the four components of its climate. And then explain which factors most affect that area's climate and how. Okay, so an apply your knowledge question about factors affecting climate. All right. Second thing, climatograms. Okay, we talked about this yesterday when we went over biomes. Oh, we got to finish those. Okay, we'll finish those in a minute. Okay, climatograms. There's going to be one on there, and what you're going to have to do is tell me what biome does it come from. Okay, so you got to. That means you got to look at it and go, okay, I know that this climatogram is saying that the temperature changes a lot during the year, which means this place is not near the equator. Okay, and then look at where the temperature goes. If it goes deep into the minuses, then we're probably not looking at any of the temperate types of climates. We're probably not looking at like temperate deciduous forest, right? We're probably not looking at desert. We're not looking at any of that stuff. We'd probably be looking at like tundra, okay, or taiga, maybe on the outside prairie, okay, something like that. Then I would look at rainfall, right? Rainfall can be kind of your kicker, right? It's okay. It's really, really low, and there's a little spike in kind of late summer, early fall. All right, well, it's taiga then. Okay, just that's the kind of thing. You're going to have to look at the climatogram, and then part of your answer will be telling me what the climatogram says. Okay, so that shows me I can interpret this climatogram. Then the second part of the question will be, it's this biome, and here's why. Okay, everybody follow there. So there needs to be some explanation. I'm not giving you 5 marks for going tropical rainforest and then getting out of there, right? Okay, you got to tell me more than that. That's 1 mark. Okay, I need some explanation as to why you think so. Okay, on that note, we should do the rest of the biomes here. Yes, I am. Right after we do the review here. By the way, I'm still missing a bunch of those. A bunch of people didn't hand that in yesterday. Okay. Okay, we left off right here, right? And I was telling you about the snow, okay? And how if you compact it, it doesn't insulate anymore, okay? So we'd already talked about that some animals will leave the taiga, okay? They'll migrate away for the wintertime. Some of them will stay, okay? Those that stay may hibernate or stay active. The problem with staying active during the winter is how much food is going to be required for you to do that, and the lack of available food during the winter. Right? So if you're an animal that's going to stay active, you have to have a food source that you can rely on even in the dead of winter. Right? Deer and caribou and things like that, they have alternate supplies of food that they can use during the winter. Deer will chew on the bark of trees, okay? And they'll get through the bark, and then they actually eat the kind of frozen or hardened sap. Okay, that's on the tree. You can often see the scars on the tree from a deer doing that. Okay, caribou will dig holes in the snow and eat what's called reindeer lichen. okay, which is a lichen that grows on the ground. Even under the snow, it can still grow, okay, and they eat that as a food during the winter months. So that's the big problem for most animals. They hibernate simply because of the lack of available food. Not so much that it's cold, but there's nothing to eat. Okay. Okay, other things about the taiga and the boreal forest. Obviously, chemical cycling is really, really slow, right? There's lack of moisture. There's cold temperatures that persist for 8 months of the year, okay? And these are not conditions that are conducive to things eroding or rotting or quickly decomposing. So stuff falls in the taiga and it stays on the ground and rots for years and years and years, okay? So it's really, really, really slow. Okay, tundra, okay, Arctic and alpine tundra, because there's two kinds of tundra, right? Arctic tundra is the stuff you find north of a certain latitude. Alpine tundra is the tundra you see that is above the tree line in the mountains, okay? They are very similar in terms of the types of plants and animals that are present, okay? What's different is that you can find alpine tundra anywhere there's a tall mountain. You can only find Arctic tundra in the Arctic, okay, above a certain latitude. The determining factor to where the tundra starts is temperature. Okay, that's why you can find it at the top of tall mountains. As you go higher up, we already said, altitude affects temperature. About 6 degrees for every 1,000 meters up. Okay, so the higher up you go, the colder the temperature gets. Okay, that's what's going to determine whether trees are present or tundra is present. Right? So the tundra is really just an Arctic grassland, short scrubby grasses, okay, lichens and mosses and things like that that can grow once the snow cover retreats, and then they'll be recovered quickly. Okay, you can see here there is still snow present in this picture, even though it was taken on the 6th of July, a long time ago, but the 6th of July. Okay, right? So it's there's still snow present and can be snow any month of the year, okay, in a place like that. Now, obviously, for climatograms for a tundra biome, okay, look at where our bell curve for temperature sets up. The line going across here is 0 degrees Celsius. Okay, so we got a bell curve, but it is shifted really, really low, right? And that's what you need to look at. A bell curve tells you it's not at the equator. Where the bell curve is tells you how far from the equator it is. Okay, the lower that bell curve is, right, the higher or further from the equator that that biome is going to be. Now, if you look at the precipitation here, the size of those bars is a bit misleading because of the scale. Right? If we're looking at the scale here for precipitation, even though this bar is really tall, that's only 60 millimeters of rain. Okay, 6 centimeters of rain in a month, in their wettest month. So this is still a fairly dry biome, right? And yeah, they get snow in the winter, but remember what we said about snow. If you melt 10 centimeters of snow, that's the equivalent of 1 centimeter of rain. Okay, so it's not a lot of precipitation in that area. Okay, so that's why, again, it's cold and there's not a lot of moisture, so you're not getting big, complex plant growth. All right. So vegetation, okay, tundra actually means treeless, okay, and so it's defined by the timberline or tree line in the mountains and high latitude for the rest of it. Okay, tundra vegetation is a few hardy species of low-growing sedges, grasses for some reason it's in there twice, dwarf shrubs, lichens, and mosses. Okay, snow cover is important because it provides shelter from cold, icy winds. Okay, especially in the alpine tundra, ice crystals get blown around by high winds, and that can be essentially the same as being in a sandstorm if you are a plant. Okay, it's like a sandblaster. Those ice crystals will just peel the tissue right off. Okay, for us it's not as bad. I mean, it hurts if you get ice crystals in the face, but because we're warm, they typically melt fast, and it's not as painful. But if you're a plant and you're frozen, okay, icy winds blowing across you are not going to help your situation. So you often see stunted, weird shapes for plants that grow in the tundra. Okay, and you can see again here, there's still lots of snow. I think I cut the date off of that picture, but that would have been taken around the same date as the other one. I think that was the 6th of July. It was the same trip. So, okay, still lots of snow, and as you can see, there's no trees anywhere there. Okay. All right, that's it. Now we're done. All right, so back to the review here. Okay, so like we said, you're going to have to be able to interpret climatograms, and we said how. Okay, energy transfers on Earth. That was lesson 3. Okay, we talked about the role of the atmosphere, the role of the hydrosphere, and the role of the lithosphere in transferring energy, absorbing energy on Earth. Which one is most important for transferring energy from place to place on Earth? Okay, convection is the most important mechanism. Which part of the Earth is most important? Atmosphere. It's the most fluid. It touches everything. Okay, so we've got the atmosphere being the most important part, the most important mechanism being convection. Now, in order for convection to happen, energy still has to be absorbed by the Earth, right? And we said 3 things can happen to energy when it strikes the Earth's surface. One of them is it can be absorbed. What determines how much of it is absorbed? Looking for one word here. Albedo. Okay, the albedo of the Earth's surface determines how much energy is absorbed and how much is reflected. A high albedo means a lot gets reflected and very little is absorbed. A low albedo means a lot of absorption, very little reflection. And we talked about how in the wintertime we absorb very little because the ground is covered with snow, which is white, and that has a very high albedo. Whereas in the summertime, we have plants growing, dirt exposed, rocks exposed, they're darker in color, and we absorb far more energy in the summer. Okay, everybody follow there. Okay, if it gets reflected, which is the second thing that can happen, okay, basically there's no change in temperature and no change in energy because it just bounced off, right? But reflected light may go back up into the atmosphere and be trapped by greenhouse gases or other atmospheric phenomena. Okay, so it could still come back and be absorbed later. And what's the third thing? Reflection, absorption, and plants do this. Right, photosynthesis, conversion of the energy, right? 3 things can happen. It can be reflected, it can be absorbed, or it can be converted by plants using photosynthesis. The conversion is really important. It's the only way the light from the sun, which is our only source of energy, gets turned into useful energy for other organisms. Okay? If it wasn't for that, if it wasn't for that conversion phase, we wouldn't be here. Okay? We need to have a source of energy other than the sun because we can't use the sun's energy directly. Right? We have to be able to eat other things. All right, so energy transfers on Earth. The atmosphere absorbs radiation and transfers using convection, okay? And we call that convection wind. Remember, latent heat also moves through the atmosphere, okay? And that latent heat can be transported by the jet stream. All right. The lithosphere, again, it absorbs energy in the form of radiation, but can only transfer it by conduction, and that's that process where the atoms or molecules run into one another, right? They're tightly packed and they just bump into each other. It's not going to be transporting large amounts of energy over great distances because it's just not efficient enough to do that. The most important role of the lithosphere is absorbing energy and providing a place for plants to grow so that the conversion of energy can take place. Okay, and remember that that absorption of energy is determined by albedo, which we talked about a minute ago. Okay, and then we had the hydrosphere. Okay, the hydrosphere can absorb energy from radiation. They all can. Okay, and it can transfer energy by convection. Convection in the hydrosphere happens by ocean currents. Okay, and of course the hydrosphere is where the whole process of latent heat begins. Without the hydrosphere, there'd be no water to evaporate. Okay, we talked about this just a minute ago, the 3 things that happen to energy when it encounters any place on Earth. I guarantee you I'm going to ask you a question straight out that is about that. Okay? I might specify a specific location on Earth, but I'm going to ask you that. Okay? You would have to base your answer on the properties of that location, and I'll make sure I pick a place you're familiar with. Something to think about, though, in terms of that, is that I'm going to be talking, or I'm going to want you to explain to me what's happening in this place in a natural sense. Okay, so yes, energy can be absorbed, it can be reflected, and it can be converted by plants. But I'm not going to want you to mention things like, well, if there's solar panels out there, they can turn it into electricity. We're talking about the natural systems here only. Okay, you know, I wouldn't want you mentioning things like, well, there's buildings and there's roads and there's things like that. Okay, I'm probably going to specify a place that doesn't have that stuff. Okay, or I'm going to specifically say a natural area near this place. Okay, everyone follow on that? Okay, so the 3 things that can happen, we said absorbed. Okay, if that happens, there's going to be an increase in energy and an increase in temperature. Okay, it could be reflected. So there'd be very small or no change in energy. And then the last thing was that it could be converted, okay, by photosynthesis, changing sunlight into fuel, food energy. Okay. I'm also going to ask you a question in the written response of this test about specifically the 3 methods of heat transfer: conduction, convection, and radiation. And the question is going to be another kind of apply or application type of question. I'm going to ask you to build something. Obviously not build it, but design it. Okay? And what I'm going to ask you to design is one of 2 things. I'm either going to ask you to design something that could keep something cold, or design something that could get something heated up quickly using the 3 methods of heat transfer and the sun as a source of energy. Okay? So remember, solar panels do not use heat transfer. Okay? So you can't just say, well, it's surrounded with solar panels and then do this. Okay? Remember, we're looking for physics only here. Okay? Conduction means I could transfer heat in by the movement of particles, or I would keep that out by doing something. Okay? And this was the part of the lesson that I actually wasn't here for, but it was taught to you in the podcast. Okay? We talked about how insulation in your house works in the podcast, right? It has those air spaces. Air spaces prevent conduction because the particles are too far apart to run into each other. Okay, insulation also prevents convection because the air is trapped and it can't circulate. Okay, if a convection current can't get set up, convection can't happen. Right, that's why insulation in the form of fiberglass or styrofoam is so good. Right, and then to prevent radiation, you just need to reflect it away. Or if you're trying to heat something up, make it really dark in color, then it'll absorb lots. Okay, so again, and apply your knowledge question that'll involve you designing something or evaluating the construction of something. I may have, here's a structure. Okay, tell me how it's going to keep you warm or cold or something like that. Okay, everybody follow there. Okay, then we talked about winds. Okay, we talked about the trade winds. We talked about the Coriolis effect causing prevailing winds. Now, is it just the Coriolis effect, or is there something the Coriolis effect has to work with in order to make prevailing winds? That's the Coriolis effect. That's the spinning of the Earth turns it. But the air is already moving. The Earth spins under the air. The air is already moving. What do we call moving air? Wind. Okay, what's wind in terms of which heat transfer method is that? Convection, right? So prevailing winds, remember, are the Coriolis effect plus convection, okay? And that convection happens because some parts of the Earth get more energy than others, and that the second law of thermodynamics gets energy on the move, okay? Trying to balance it out. Okay? I would imagine there will be a written response question that would have a picture of the Earth like the ones I showed you in lesson 4, right? And ask you to explain how prevailing winds could happen. Okay, and probably one that has something about the Coriolis effect. So kind of the Coriolis effect would kind of be in there twice. Okay. All right, if I'm trying to move energy from the equator to polar areas, okay, convection's part of that. The jet stream is part of that, and the jet stream carries latent heat. Latent heat's kind of the other part of that. Okay, so that question on prevailing winds would probably also be asking a bit about how energy gets from equatorial areas to polar areas. Okay, heat capacity, expect an E equals mc delta T problem, as well as a few multiple choice questions. Okay, and then right after we talked about heat capacity, we talked about the heating curve of water and latent heat. So expect one of those problems on there as well. Okay, where I ask you, how much energy would be required to heat ice from -20 to water at 50 degrees Celsius. Okay, identify your steps, do your calculations. Okay, and that one's kind of a big mark question because there's lots of steps. And again, those numbers and those formulas are all on the test. It's not something you need to memorize. Okay, and then, like we said, you're going to have a question that has your heating curve of water, okay, your heating curve of water problem, right? So like I just said, the heat ice from -20 to water at 50, or heat water from 50 to steam at 120 or whatever, just like the ones we did in class. And then the last thing, we've kind of already talked about this, but the stuff on biomes, climatogram, okay, in the written response, and then some multiple choice questions that have a picture and a description of the biome. You identify it, okay, in the multiple choice. This is the shortest. This is the shortest of your 4 tests. Okay. There's 25 multiple choice, and there's 9 written. There's 46 marks in the written. So it's your shortest test by a fair margin. Okay. Is this test a real opportunity then though? Right? Like there's not that much stuff on here. Okay. I'm asking the same things in several questions. Right? So there's only a few kind of big themes or big concepts in this unit. So know them well. Okay. If you know them well, then this test becomes an opportunity to boost the exam portion of your mark. Okay, but if you say, Mr. Coder said this test was easy, which by the way I didn't say, okay, then you'll approach it that way and you won't know those 4 or 5 main ideas and you'll get burned every time I ask about them. Okay, that's not the situation you want to be in on Monday. Okay, you want to know those 4 or 5 big themes so that every time I ask about them, you know what to write. Okay, all right. The climatogram on your review sheet obviously has the name of the town at the top. The one on your test does not. Okay, as that would kind of give away which biome it is. So it doesn't have that. But that one, I left it on there on purpose so you could kind of confirm your answer a little bit when you were done. Okay. Anything you want me to go over or review other than what we've gone over here? Okay, well, get working on that sheet then. If something comes up, just ask. Pardon me? Oh, right, the climatogram activity.